This is the first of 3 short videos reviewing solving systems of equations. Solving a system of equations means we must find the values of the variables that satisfy all equations in that system. Here we will stick to solving a system of 2 linear equations for which we will be finding the values of 2 variables. There are various methods for solving systems, but here we're going to focus on a method called substitution. So our example gives us 5x minus 3y equals 11 and y equals 2x minus 3. We are trying to find the value of x and y that make both these equations true. Like the name of this method implies, we're actually going to do some substitution, and here a nice substitution would be in our first equation, anytime we see the variable y, we can plug it in with another equivalent expression, which is given in equation 2. So if I take my first equation and start rewriting it, 5x minus 3, when I hit y, I'm going to replace y with 2x minus 3, because our second equation tells us y is the same as 2x minus 3. Now I have to finish off my first equation. It's still set equal to 11, but hopefully what we notice is that this new equation is just an equation solving for x, and this is something we can do. So if we continue solving, we have 5x minus 6x after distributing, plus 9 after distributing, equals 11, and hopefully this looks like a friendly linear equation. So I'm going to combine my like terms of 5x and negative 6x to get negative 1x, plus 9 equals to 11. I'm trying to get x alone, so I'll go ahead and subtract 9 from both sides of our equation, leaving negative x is equal to 2. I want x alone. I still have negative x, or negative 1x, so I could divide both sides by negative 1, and now we have x equaling negative 2. So this is looking very good, but if we stop here, we haven't really offered a complete solution, because solving a system in this case means finding x and finding y. So we now have to figure out a way to get the value of y. A great way to do it when you're using substitution is to go back to the equation where you got your substitution from. In this case, that means looking at our original second equation. If I take this equation, y equals 2x minus 3, but replace the value of x with the solution we just found, which was negative 2, we'll be able to find the value of y that corresponds to it. So here, that looks like negative 4 minus 3, or negative 7, as the solution for y. When you're solving systems, in this case, it's common to write your solution as an ordered pair. So here I'll just leave the solution as negative 2, negative 7, and what this means graphically is that the 2 linear equations we started off with would, when graphed, intersect at negative 2, negative 7. So this is solving by substitution. If this method feels pretty comfortable, you are more than welcome to go and find the practice exercises for this topic. If you'd like to see the other methods of solving, please look at videos 2 and 3.